Today, we are going to be looking specifically at chords and finding missing parts or missing values of a chord. So there are three different theorems, three different rules that we are going to look at, and then you will get time to practice those. So the first rule that we have is called the chord product. So this means that there are two chords in the picture. So the theorem, or the definition for this, is that the product of the lengths of the segments are equal. So whenever we hear product, we want to think multiplication. So what this is going to look like is that we will have part times part is equal to a different part times part. So let's look at an example with this. So here you can see we have two chords. Remember, with a chord, it's all inside the circle. Nothing goes outside. So what we want is we want to take one chord, so we'll start with this pink chord, and we want part times part. So I want 4 times x. And that's going to be equal to our other chord. So here's my other chord, and the two parts of that are 5 and 8. So I want 5 times 8. So I could work this out, and let's see, 4 times x is 4x, 5 times 8 is 40, and then to get x by itself, I would divide both sides by 4 to find that x equals 10. If you don't want to do that, or you want to check your work, check your math, you can also go to your calculator and you can go to Math, Up, Enter, go to the numeric solver, and here I can type in 4x, and on bottom I can type in 5 times 8. Oh, parentheses, 8, there we go. 4 times x, 5 times 8. When I press enter, alpha graph, I'll get x equals 10. So either way, you're still just solving for x to get x equals 10. So this chord, that's definitely the easier one. You just multiply the parts together and they're equal. All right, let's look at number 2. This one is the secant product theorem. So here we've got two secants that we're going to be looking at. So if you remember a secant, it has 2 points on the circle, but it goes past the circle. So we're going to have parts that are outside of our circle. So here, the product of the whole length on one secant and its outside segment equals the product of the whole length again of the other secant and its outside segment. So again, we're looking at product. So we're going to be multiplying, but it's going to be a little bit different on this one. So I'm going to use the example, use the picture to show you what it means by whole length and outside segment. Because if you just look at the words, it's a little weird. So let's look at the example to know what these words mean. So here's our example, and you can see here I've got one secant, and it's got part of it inside, part of it outside. Then I've got another secant, again, part of it inside, part of it outside. So our what we want is we want the whole part times the outside part. So if I look for the whole thing, that means I want from start to finish. So I want 5 and 3. So how I'll get that is I'm going to do 5 plus 3 to get the whole thing. I want both together. Then when I look at the outside, I want the number that is not in the circle, the one that is outside of the circle. So when I look, 5 is in the circle. Here's our circle. 5 is inside. 3 is outside. So I want this 5 plus 3 times 3. Then I'm going to look at the same thing for the green line. So again, I want the whole thing. So I'm going to have x plus 4. And then I want the outside piece. So here my outside piece is 4 because again, it is outside of the circle. So I can go through and solve this, or you can put it in the numeric solver. If I solve it, what I would do first is 5 plus 3 gets me 8. So then I have 8 times 3, which is 24. Then on this other side, I would need to distribute this 4. So I would have 4 times x plus 4 times 4. So that would get me 4x equals 16. If I continue solving this, oh, this needs to be a plus here. So this will be plus 16. So I need a minus 16 on both sides. 24 minus 16 is 8 equals, I bring down the 4x, those 16s go away, and then I divide both sides by 4. So I end up with x equals 2. So again, I can check this in the numeric solver. So I'm going to go math up, enter, clear out this first one, and I'll type parentheses 5 plus 3 parentheses 3 on the outside. And in E2, I'm going to have parentheses x plus 4 parentheses and 4 on the outside. So this, oh no, I didn't put a 3 on the outside. There we go. So my calculator matches what I wrote. So when I press alpha graph, I get x equals 2. So again, you can work it out if you want. You don't have to. You can just go straight and put in the calculator. Either way, you get x equals 2. All right, and our last one we're going to look at is probably the weirdest. It is called our secant tangent product theorem. So we've got a secant on this one, and we have a tangent. So here, this is the product of the whole length again of the secant and its outside segment. So the secant part will be the same as we just did, whole length times outside. And that's going to be equal to the length of the tangent segment squared. So if you remember squared, this is where we've got side times side, which equals side squared. Okay? So again, this is going to be a little weird, but let's put it together with the example. Pictures will make a lot more sense than words. So here is our example. And so first I'm going to look at the secant. My secant goes through the circle to the outside. So again, for secant, I want the whole thing times the outside. So if I look at the whole thing, I want from start to end, so x plus 9, times the outside here, and outside is 9. And that's going to be equal to, if I look at my tangent, again, that just touches the circle and stays outside, that tangent is 15. So I'm going to have 15 squared. So if I were to work this out, first I would distribute the 9. So I would have 9x plus 9 times 9. So I would have 9x plus 81 equals 15 squared means 15 times 15, and that's 225. So to solve for x, I would subtract 81 from both sides, and I need more space to write. I would get 9x equals 144. Divide both sides by 9 to get x equals 16. So you can work out the algebra, you can do that. Again, you can also go to our numeric solver. Math up, enter. In E1, I'm going to have this parentheses, x plus 9, parentheses, 9 on the outside. And in E2, I'm just going to have 15 squared. Then I'll press enter, alpha graph, and again, I get that same answer here. It's x equals 16. I got x equals 16. So that means these, either way you solve it, you should get the same answer. So you have a class kick. I think there are 9 questions on it to practice with these. If you have questions, please ask me, please ask Miss B. I know parts of this are a little weird. So ask us until you understand. Try it. If you mess up, try again. All right? Good luck.